Good day to you. This is Anagalactic bringing you a wrap up. I had made two promises that I have not yet fulfilled, and I intend to fulfill those two promises now. So this will be swift, but it will be divided into two parts, which may seem disparate, but let's just name them. We discovered what is superposition. And it's remarkably simple once it's seen, but you can always say that after the fact. Superposition was not easy for science to see. But what I had promised was to go on with something that I touted to be equally fascinating, and that is the superpositional logic system. That's not exactly the same thing as what we had talked about, which was the physical manifestation of superposition, which refers to the coordinated state of what appear to be two separated but coordinated particles. This has led to an extraordinary branch of mathematics, but this mathematics actually relies, or I will say is related to, directly related to, a logic system that was not, I don't believe, familiar to the logicians that preceded the quantum generation. Superpositional logic is new in the 20th century. So that is the first topic I'd like to cover, just to give an idea of what is meant by superpositional state logic, which is a specific type, and the more general category, in logicians' terms, superpositional logic, as a systematic formalism. Superpositional state logic is actually an application of that to state mechanics, also known as quantum mechanics. That's why sometimes you hear it referred to as state mechanics, because that is what is done to make measurements. But then you also hear of the wave equation. Well, the wave equation is not exactly wave mechanics. That equation is probabilistic, and that is the heart of the quantum paradox. Is we can't accept probabilistic distributions without an explanation. Well, mathematically there's an explanation, and that's really all we have. So that's not really enough, because what is missing? Well, geometry is missing. And that has been stated. I was very gratified to find out that that has been stated. It's not a common statement, but the nature of superposition is physical. It's a physical violation of special relativity, which in our last presentation on this topic, which was 2 videos ago, because the last one was on the black hole. Well, that's the second topic we're going to cover, because I had made another promise to show you what the supermassive black hole is, what it actually is. Well, as far as science knows. Well, there are 2 theories then, because you know we already know what it is according to the model. Oh, the supermassive black hole. Let's change the term I had promised to reduce that to SMBH, because, come on, supermassive, that just means, that's all right, supermassive, but then black really doesn't mean anything, and hole actually does mean something, but it's embarrassing. So there is literally a hole at the center of this supermassive black hole, but let's rename it. We reduced it to SMBH, but that's an acronymism. Let's give it a formal name. We name things after men. It's unbelievable. I don't like that trend, so I don't want to get emotional right now. I want to stick with a topic and not, show how sensitive I am to naming issues. It is my job, so forgive me. But anyway, it's a panther. Well, isn't that nice? Black Panther? Come on. You don't have to say black, but black is there. And the panther has a hole. But it's usually, concealed by nature behind the cat's tail. And, you can't help but look at it because usually the tail is up. So you're going to see the hole in the panther. But you can think of it as a black panther if you insist on the blackness. You see, I don't think that's very scientific. Yes, it's black. You could say that. But come on. We're supposed to be scientists. Panther. There's another reason. By the way, I just thought of the whole aspect. This is suitable for American audiences. Never mind, but we've been isolated a long time from Europe. I'm just going to put it that way. But the word whole is objectionable, and I'm just, of course, being silly by comparing it with, what in biology would be called the anus. All right, so are we done with that? I'm sorry, but I told you this is my job, and so Panther, I really insist on this. And I'm sorry if that causes a problem for my listeners in any way in the future. You're aboard. You know what I mean when I say Panther, but here's the other thing that makes this so exciting to me. I know, but I'm sharing. Okay, I'm sharing. I'm allowed to do that. You might learn something you don't know, so just listen to the old professor because I have some goods. I'm not saying this is part of it, but I actually am. I'm going to say that. The leaping panther. The leaping panther. So that is what I want to cover today. You may already guess what I mean by that. It certainly seems obvious in retrospect, so let's get to the point. What actually is a panther? Well, it has phases. What are being touted as these, gluttonous objects has to do with identifying the locus of gravity in a very large system, which in all cases is the galaxy. So this is a galactic scale object, but it has a geometric position which is well worth stating out loud. It's always at the center of the galaxy. Well, we take that for granted, but actually that's highly significant. The center? How did it get the way it is? Well, of course we'd love to know that, but why would we love to know that? Because it explains the rotational profile of the galaxy. We can now measure the rotational profile of galaxies, so we can tell to a high degree of precision now with multiple spectroscopic photographs that the stars on this side of the galaxy are going in a certain velocity, which is a direction, as you know. Speed is just distance over time. But velocity is distance over time in a direction, and that's why vector calculus rules the roost, Daddy-o. You want to get anywhere in technology, you learn vector calculus. It's very easy to say now, but you could say that for the past 120 years. Vector calculus rules the roost. What's interesting to add to that, which should be stated right away to freshmen in anything, when you use that calculus the way it's used in technology, vector calculus is by far the most difficult form, of course, in an already abstruse realm of calculus. But you will be using complex numbers exclusively. I don't hear that stated very often in STEM introductions, and I recently was in a STEM program. I went back to school several times in my lifetime to study things. So I am in a way, an intellectual, I guess. Those about my only credentials, though. Although I am a morphologist, I'll say that. One has to earn these names, and it's easy to give oneself titles and names. But that covers our expose of the supermassive black hole, is that it has stages. But of course, I could give a series of 12 one-hour lectures on this topic that would have you galvanized. Because by the simple process of discerning what is a panther and finding out that it's identical with a quasar, right? It's identical with the center of every galaxy. That's really significant in morphology. You're studying the formation and form of galaxies. That's my specialty. So that's why I was interested in the Panther. But to discover that the quasar is a leaping panther, that I need to give another lecture series on that will be separate, because that's my favorite topic, but it's way off of what we're studying now, which is quantum mechanics and space-time. I hope I've given you some interesting insights into those two leading edge topics, but it's now time to go on. But to wrap this up and then go on in the next presentation with some more amazing insights into the Boshkovich force curve, oh, we're not done with that. But to wrap up the comment on superposition, you should be comfortable with the fact that entanglement, first of all, is the wrong word to use. It's a, or at least it should always be explained if you insist on saying that the particles are entangled. It's rather misleading to say that when the actual condition of the particles is coordinated. The coordinated state, and I've shown you this before, leads to our ability to show that quantum mechanics violates space-time. It violates space-time relativity, to be more precise. Because when you change one state, we've determined, I believe this has been proved, and so do most other scientists now. It took decades to prove this using Bell's inequality, but that's another story. The point being that superpositional logic is worth a whole series of lectures itself, and these would be lectures. It would be kind of dry, wouldn't it? I don't believe in dry lectures. So I mean presentation, because isn't that a more exciting word? I mean, as I've said before, which one would you rather go to if you had a choice? A lecture or a presentation? Well, I think we all know, right? So, but as for diagrams, in July, we're going to be stepping up our game here at Anagalactic. There will be diagrams, a plethora of diagrams that we'll refer to over and over again in order to point out things so that there's a focus of attention for memory. It's really, I love diagrams. I'm not against them, but it's work. Don't forget it's in the hundreds here in Chico right now. And the old professor just doesn't frickin' want to work. I'd rather just talk to you because really, that's more important at this point. You need to know what I know so that the proofs will be all the more precious to you. Yes, you want the proofs. Well, this is pretty far-reaching stuff. A new number system, a new spherical geometry. It's all simpler. It just solves an amazing slew of problems in all directions. Just everything suddenly becomes ironed out, and now we can start to make progress again. Well, I would have to say I'm duly elated. So that covers, we're still under 15 minutes. That's all I wanted this to be. But that there will be a future series. As I have given series of lectures on these topics in the past, I never ask people to go back. But you might be interested. I did make those lectures for a reason. So if you want to, just, well, leave a comment if you want me to point out where they are. Otherwise, you'll have to sift through. I have over 200 that are public domain, and another 300 and more that are privatized. That's roughly speaking. So that's what we wanted to say here, is that the supermassive black hole, what it really is so far-reaching that I could write a 2-volume set of books on the topic, but I'll be giving you all that information, all of which is new. It's a reinterpretation of the data we already have, which is magnificent. It's just tragic that it's held back from the public. I'm serious. To study these galaxies is absolutely the high point of a scientific career. There's really nothing further to ask than to have access to these photographs of these galaxies. But we as rational human beings are following a blueprint to ask questions. I fully believe this, and I do not hide the fact. I consider it to be, you could talk about it in religious terms, because we're blueprinted to do this. Well, 99% of our blueprinting is to have fun. Really, come on. But 1% is just dead serious, is figure out why the moon travels the way it does. It changes phases, and it just goes out as far as man's mind can reach. Well, let's do it. Science is synthesis. What have we discovered? We discovered a boatload of overwhelmingly beautiful things. But the panther is also beautiful. And that's why I don't like Tammy the glutton having a column on the panther where the panther is as fat as she is. I don't think that's a healthy image of the panther. But the panther has a hairball. And I discovered that because it's directly implied by spherical geometry. That instead of there being a singularity at the center of the panther gets a hairball and has to cough it up. So the take home is the panther, which formerly was called the SMBH, which prior to that was called the supermassive black hole. By the way, there are ultra massive black holes that have been theorized, the upper limit for how big a black hole can be. Well, what they're really saying is how big can it be before it explodes? That is a quasar, the beginning of a galaxy. This will explain for the first time in astronomical history Hubble's tuning fork. That was sought by a whole generation of scientists around the 60s, was to try to get an explanation for the difference between elliptical galaxies, which are spheric really, spherical galaxies. They're a little dull because they're reddish objects. They have older stars, and so they're not nearly as tantalizing as the beautiful blue-white diamond spiral galaxies, which come in two types. One has a bar, very difficult to explain, and that is a linear phenomenon, really undermining my continuous reinforcement of the rather grandiose statement that there's no linearity in the universe. Well, of course there is. But at the fundamental level, at the two edges, there's only sphericity. Only sphericity describes the collision between two particles, which was sought for well over a century by Newton and Leibniz and Boschkovich, our hero. We'll be back with more of Boschkovich's force curve. That's what we're concentrating on now, because it gives us a definition of space-time and a definition of the quantum. Solving the quantum paradox and energizing Einstein's space-time as if is a jump from fission power to fusion energy, is to translate the space-time formulation of Einstein into spheric geometry where everything makes sense. There is a trade-off, though. There's a reason no one saw this. It has to do with orthogonality. This is Anagalactic, promising our short series, reiterating my prior lecture series on superpositional logic. Actually, I don't believe I've given a series on that. No, I haven't. So the superpositional logic series, including superpositional state logic, using the Bloch sphere and Dirac notation. You want to have the golden road to understanding Dirac notation? I've got it, but I can tell you no one else does. It's remarkable what Dirac came up with. And there's much more to say about that, and on superpositional logic, and on the Panther. We'll have all of this coming up. But first, let's extend space-time into the space age. Let's get the correct definition of universal geometric space so we can see better. All right, and keep looking up at night. It's a good time of year to look up at night. Yeah, that's the best time you'll spend on Earth. This is Anagalactic, bringing you the secrets of the universe. Stay tuned.